I'm analyzing a problem where a linear discriminant analysis, LDA, model, trained on the MNIST handwritten digit dataset, frequently confuses the digits 4 and 9. I need to figure out why this is happening. The MNIST dataset is a large database of handwritten digits commonly used for training and testing in machine learning. LDA is a statistical method used for classification. I've trained an LDA model on the MNIST dataset, but it's not performing well. Specifically, it frequently mistakes a 4 for a 9, and vice versa. I need to determine the causes of this high error rate. One possibility is that the features I'm using to represent the digits aren't good enough to differentiate between 4s and 9s. For example, maybe the features don't capture the presence or absence of a closed loop, a key visual difference between the two digits. This is a plausible explanation. Another possibility is that the statistical distributions of 4s and 9s are too similar. LDA assumes that different classes have different covariance matrices, which describe the spread and orientation of the data within each class. If these matrices are very similar for 4 and 9, the LDA model will have trouble separating them. This is also a plausible explanation. It's possible I chose the wrong algorithm for this task. Some algorithms struggle with high-dimensional data, like images, but this isn't inherently the case with LDA. I believe other factors are more likely responsible for the misclassifications. This option seems unlikely. Maybe there is a problem with the data itself. If I have many more examples of one digit than another, the model may be biased towards the majority class. However, I don't think this is the main reason why my model specifically gets 4 and 9 mixed up. This is less likely than the other options. This question asks you to identify the reasons why a linear discriminant analysis, LDA, model might struggle to differentiate between the handwritten digits 4 and 9. It's a great chance to check your understanding of LDA's strengths and weaknesses. Let's think critically about the possible explanations provided. I think this is a plausible explanation. If the way we represent the digits as data, features, doesn't highlight the key differences between 4 and 9 feet, then LDA will obviously struggle to tell them apart. Imagine trying to distinguish two birds based only on their weight. If they weigh about the same, you won't differentiate them. I agree, this is another likely reason. LDA assumes that different classes of data are spread out in different ways. Each class has its spread, represented by a covariance matrix. If these spreads are very similar for 4 and 9, the LDA model's boundaries, discriminant functions, between these classes will overlap significantly, leading to errors in classification. This is like trying to separate two overlapping clouds. It's hard to draw a clear line between them. I disagree. While LDA can have issues with high-dimensional data, that's not necessarily the biggest reason why it fails here. Problems with features or data are more likely culprits. Switching algorithms isn't always the answer. We should first improve the way we present the data. This is a less likely explanation. While data imbalance can affect performance, it wouldn't specifically cause confusion between 4 and 9. It would more likely lead to overall poor performance or a bias towards the more frequent digit. This simply describes the context of the problem. Our LDA model has trouble classifying handwritten 4s and 9s correctly. We are investigating why. This is the database we are using. MNIST is a large database of handwritten digits commonly used for machine learning tasks. It's well suited for this type of problem. We see the problem. We're using linear discriminant analysis, LDA, to classify handwritten digits. The model is confusing 4s and 9s, which means something is wrong with the approach. Let's figure out why. This is a plausible reason. The features we use to describe the digits might not highlight the important differences between a 4 and a 9. For instance, if the features don't capture the presence of a closed loop, which is key for a 9, LDA can't distinguish between the two. Makes sense, right? LDA assumes the data is normally distributed and that classes have similar covariance matrices. If the 4 and 9 have very similar covariance matrices, then their discriminant functions, the boundaries LDA uses to separate classes, will overlap. This overlap leads to many misclassifications. It's like trying to separate two overlapping clouds. I don't think that's the main reason. While high-dimensional data can be problematic for LDA, it's not inherently unsuitable. The main issue here seems to be the similarity between 4 and 9, not the dimensionality itself. Let's focus on fixing the data or features first. Let's not jump to conclusions. Imbalanced data is a problem, but it's less likely to specifically cause the 4-9 confusion. Data imbalance usually leads to poorer overall performance, not necessarily this specific type of error. I think there's a more important factor at play here. Hey Vamsi, this is about a common problem when using linear discriminant analysis, LDA, a machine learning technique, to classify handwritten digits. Specifically, it focuses on why an LDA model might frequently confuse the digits 4 and 9. We're going to dive into the reasons why this might happen. Vamsi, we're troubleshooting a machine learning model. We are using a linear discriminant analysis, LDA, model, which is a fancy way of saying we're trying to draw lines to separate different types of data. In this case, our data is handwritten digits, and our model is struggling to tell the difference between 4s and 9s. That's the question we'll answer. Vamsi, I think a big reason this is happening is because the computer might not be looking at the right things in the images of the digits. For example, if we aren't telling the model to focus on details like the closed loop that distinguishes a 9 from a 4, it will have trouble sorting them. It's like trying to tell the difference between two similar-looking fruits without having the right tools like a magnifying glass. Vamsi, LDA assumes that the data for each number, 0 to 9, is spread out similarly. If the data for 4 and 9 are too similar in how they are spread out, the model gets confused. It's like trying to separate two overlapping clouds. It's hard to tell where one ends and the other begins. This option is about the limitations of LDA. It is usually not as good for complex problems involving a lot of data like images. However, the confusion between 4 and 9 might not be simply due to the type of algorithm used. It's more likely that the problem lies in how the images of the digits are processed and presented to the algorithm, rather than the algorithm itself. Vamsi, if there are far more examples of one digit than the other in the data the model learns from, that could lead to bias. However, that wouldn't specifically cause a problem between the 4 and 9, as much as it would affect the overall performance of the model. It's less likely to be the main cause of confusion between two visually similar digits. Vamsi, because we're looking for multiple reasons why the model is failing, you can pick more than one answer here. The choices we talked about cover possible explanations. I'm looking at a problem where we're using a linear discriminant analysis, LDA, model, a type of machine learning algorithm, to classify handwritten digits from the MNIST dataset. The MNIST dataset is a large database of handwritten digits, commonly used in machine learning. The LDA model is struggling, specifically with confusing the digits 4 and 9. I need to figure out why. It's a digit detective case. LDA, which stands for Linear Discriminant Analysis, is misclassifying 4s as 9s and vice versa. I'm trying to find the most likely reasons why this is happening in the context of the LDA algorithm and the nature of the data. One reason could be that the features we're using to describe the digits, the information the computer uses to tell them apart, aren't good enough to differentiate between a 4 and a 9. For example, maybe we are not considering crucial differences like the closed loop in a 9. If the algorithm lacks that information, it might have difficulty distinguishing them. Another possibility is that the statistical properties of the 4 and 9 data are too similar. Covariance matrices describe how much the different features vary together. If these matrices are very alike for both digits, it will be hard for LDA to separate them. The LDA model creates boundaries to separate the digits. If the data overlap too much, these boundaries will be blurry and lead to errors. This suggests that LDA is simply a bad choice for image data, and a support vector machine, SVM, would be better. However, I don't think that's the main problem here. LDA can work with image data. The issue likely lies in the way the data is presented or the features used, not the LDA algorithm itself. It's possible that there are many more examples of one digit in our training set than the other. An unbalanced dataset can affect the accuracy of our model, but it's less likely to cause confusion specifically between 4s and 9s. Imbalance might lead to a model that's better at recognizing the more frequent digit, but not necessarily mistaken one for the other. This is a large, publicly available dataset of handwritten digits, commonly used to train and test image classification models. This refers to a specific machine learning model, linear discriminant analysis, used in this scenario for classifying the handwritten digits. LDA is a technique for dimensionality reduction and classification. These are the results of using the LDA model to classify the handwritten digits. In this case, there is high confusion between the digits 4 and 9. I'm analyzing a problem where a linear discriminant analysis, LDA, model, using Sklearn, struggles to differentiate between handwritten digits 4 and 9. I'll be determining the most likely reasons for this confusion. This sets the stage. We're using LDA, a common classification technique, on the MNIST dataset, a famous collection of handwritten digits. The problem is that the model frequently mistakes a 4 for a 9, and vice versa. This is what I need to explain. This option suggests the features used, the data representing the digits, aren't good enough to separate 4s and 9s. Perhaps they lack key differences, like the closed loop present in a 9, but absent in a 4. LDA assumes similar covariance matrices for the different classes. Covariance describes how variables change together. If the 4 and 9 data look too similar statistically, their covariance matrices are similar, LDA's separating lines, discriminant functions, will overlap, leading to confusion. This option wrongly claims LDA is fundamentally bad for images. While high-dimensional data, like images, can sometimes be problematic for LDA, this isn't the core issue here. The problem is likely in the features or data itself. This suggests that an unequal number of 4s and 9s in the training data is the reason. While imbalance can sometimes affect performance, it's less likely to be the primary cause of specific confusion between visually similar digits.